Good morning. This is Veeraswamy, working as an assistant professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the new topic in the cellular mobile communication, that is mobile communication system. The topic is the frequency reuse and channel assignment strategies. So here, before going to that, I prepared the slides by using this textbook. I referred this textbook to prepare the slides. The textbook is the Mobile Cellular Telecommunication, and the author is William C. Wiley, and the publisher is Tata McGraw-Hill Publishing Company Limited. So today's topic is a frequency reuse, channel assignment strategies. So in the last session we have discussed different types of frequency band are assigned in the wireless communication system, that is the same as the mobile communication system. So the today's topic is the frequency reuse and the channel assignment strategies. So how the frequency is allocated to the mobile unit, from the mobile unit to the base station, is the same vice versa. So which frequency band, how the frequency is utilizing by the base station to the mobile unit and the mobile unit to the base station, and how the frequency, the reuse, how the frequency is reusing by the mobile unit in the cell or the spectrum, and the channel strategies assignment. So how the channels are assigned to the mobile unit from the base station or mobile station or cell site. So here the frequency reuse and channel assignment strategy, the first topic is here, it is the cellular concept. So here already we discussed that the cellular concept topics. So how the concept, what is the concept, and how the cellular concept is implemented in the mobile communication system and the wireless communication system. So today the cellular concept is the level idea which calls the replacing a single high power transmitter with the many low power transmitters. So here I am repeating, the cellular concept is the system level idea which calls for replacing high power transmitter with the many low power transmitter. That means the single high power transmitter is nothing but here that the base station or the antenna. So the antenna is connected to the many base station, that is nothing but here many low power transmitter antennas. So the high power transmitter antenna is connected with the low power, different or many number of low power transmitter antennas. So what is happens here, the high transmitter power capacity, that is nothing but here the high power transmitter have the high frequency band, right? So that is nothing but high capacity in the limited spectrum utilization. So automatically the high power transmitter is nothing but here the spectrum utilization is very high here. It is nothing but high capacity of spectrum utilization. What is the, we are assigning the same frequency spectrum, it is utilized by the high power transmitter, basically that is high power transmitters. So the neighboring base station, so each base station is allocated to the portion of the total number of channels available to the entire system here. For example, we have taken here, this is the area which is covered by the high power transmitter, and here the many number of low power transmitters are available here. So this is the high power transmitter center point, and these are the center points of the low power transmitters. All these are connected to the high power transmitter, and here the low power station or the low power transmitter are also called as the base stations. So each base station is allocated to the portion of the total number of channels available in the entire system. So this is, I assume this is the entire system. So the number of channels are available in this entire system is assigned to the each base stations here. So the neighboring base stations are assigned a different group of channels. So why we are assigning the different base stations here, neighboring base stations are assigned to different group of channels. So to avoid the interference between the base station is nothing but here, to avoid the base station interference, we are placing here different frequency channels or different group of channels are we are placing here. So this is the, see the image here. Here this is the BTS and it is MDSO and the PTSN and the COO here. So what is happening here? This is the here mobile unit is here. Mobile unit or mobile station. So here is the mobile station. This mobile station is connected to the CO, and the CO is connected to public telephone switching network, and from the public switching telephone network to the switching telephone network to the MTSO, mobile station switching office. So from the mobile station switching office to the base station switching station or base station services. So what is happening here? The different group of channels are connected to different base station. So this is the concept here. So coming to here, next slide here, the mobile telephone system or mobile phone system. So how the mobile phone system is works in this cellular mobile communication or mobile communication system. Then see here. So here basically this is MSc1 and MSc2, and here BSc1, BSc2 and BSc3. So MCS are 2 and BSCs are 3 and the CBTS. So 1, 2, 3, 4, 5 and 6. So here BTS are total 6 and see the MS mobile stations 1, 2, 3. So 3 here. So this is the structure of the mobile phone system connected with the data interfacing between the mobile station to the base station to the mobile station. So here see the base station here nothing but here this is the base station. Next, so BTS are also there. The BTS are nothing but here base transceiver stations. So the base transceiver stations are connected to the BSC, that is a base station controller unit. So the working of the all the base station. Then see here, I will erase this one. Then you can clearly it is visible to you clear. Then see, no need of the number count. Then see here. So the mobile station is connected to the BTS, that is base station transceiver. So the base station transceivers, all the base station transceivers are connected to this is base station controller. So what is happening here? The base station controller controls all the working of these base stations, right? So again, this base station is connected to the MSC, mobile switching center. So this is the master control of the entire this system. For example, we are assuming this is a system. In this system, mobile unit is available, base station is available, base station control unit is available, and at the same time, mobile switching center is also available. So here in these all the units, the mobile switching station is controls the entire system here. So what is happening here? For example, a user is want to communicate between here. I am taking this is user 1 and here user 2. For example, the user 1 is nothing but here the mobile station 1 is want to communicate with the it want to transmit the data to the user 2 or mobile station 2. So what is happening here? The mobile station is connected to this nearest to base station. That is nothing but base transceiver station. So base station is the base transceiver station. So from the base transceiver station is connected to the control, that is base station controller. So the base station controller is connected to the mobile switch center. So what is happening? The data is from the mobile unit. For example, an image we want to transmit from the user 1 to the user 2. That image, for example, this is the image. This image is available in this mobile unit. So this mobile unit can transmit this image to the base station controller, and this base station controller is transmitted to the base transceiver. So from the base transceiver to the base station controller, from the base station controller to be transmitted to the mobile switching center. So from the mobile switching center to again it is connected to the nearest base station, from nearest to MSC, that is mobile switching center. From the mobile switching center it is connected to the base station control, or from the base station controller it is transmitted to the base station transceiver or base transceiver station. From the base station transceiver to the mobile unit 2. So this is the process, entire system. So here the main component here, the main center point here it is this one. That is nothing but here mobile switching center. It controls the entire system here in the wireless communication system. This is the mobile phone system. So how the mobile is operating and how the mobile is connected to the base station, and how base station is connected to the mobile control station or base station controller, and from the base station controller how is it is connected to the mobile switching station. This is the complete entire system of the mobile phone system. And here the each base station, just now we discussed that the each base station is allocated to the portion of the total number of channels available in the entire system. So I am repeating, the each base station. So here each base station is allocated the portion of total number of channels available in the entire system, and nearby base station is assigned to the different group of channels. And see, each base station, the previous image, each base station is connected to the total number of channels. For example, this is the base station system, that is the base transceiver station. So base transceiver station is also nothing but here base station. So base transceiver station is also called as the transceiver station is also called as the base station. So what is happening? For example, this is the entire coverage area of this base station. The coverage area, the radius of this base station. So the region, the coverage area of the base station is this one. So the total number of available channels are assigned to the base station only. But here nearest again another base station is there. So for example here 250 gigahertz I am taking here. The 250 gigahertz, within the 250 gigahertz all the channels are assigned to the base station 1, and another here. The adjacent are the neighbor channel. Again here neighbor base station is also available. For example 250 to 260 gigahertz. So in this band all the entire total number of channels are connected to this base station. So that is the meaning here. So each base station allocated the portion of total number of channels available to the entire system, and nearby base stations are assigned to the different group of channels. So what is the use of, so here for example within the radius of each base station the number of total available channels are connected to that base station only. But for the neighbor or the nearest base station, the different group of channels are assigned here. Because of here, the co-channel interference are here. What is here? The neighboring base station interference. To avoid the neighboring base station interference, we are assigning like this the channels. I am repeating. In each base station, the allocated portion of total number of channels are available in the entire system. So what we are doing? So how many number of, for example, 10 number of channels are assigned in the base station. So those all the 10 channels are assigned to the 10 frequency bands are assigned to that station, that base station only. But here the neighbor channel is also there. That is, but here the neighbor frequency band is available. That neighbor frequency band channels are allocated to the neighbor base station or nearest base station to avoid the base station interference. So here, as the demand of the service is increasing, for example here total 10 channels are available in the entire system. Those 10 channels are allocated to that base station. So here the demand is increasing. The 10 channels are not sufficient. Assuming that the 10 channels are not sufficient to cover the entire all the demand, that is nothing but here if the increasing. So for example the users are increasing, the 10 channels are not sufficient to cover or to connect the data to all the user. So the number of base stations may be increased here. So the number of base stations also we have to increase. So thereby providing additional radio capacity with no additional increase in the radio spectrum. For example, 250 to 260 gigahertz of frequency band channels are available here. So for example, only 10 channels we are separate. The separation done for this frequency band only 10 channels. So when the users are increasing nothing but the demand for the service is increasing. Then automatically what is happening here? In between this frequency band, the 250 gigahertz to 260 gigahertz, what will happen? We have to divide 20 channels here. Then automatically all the users are connected to the same frequency band without increasing the radio spectrum. So the radio spectrum, the frequency band is 250 to 260 only. But we are not increasing the frequency band. Just we are increasing the channel within the frequency band. Right? Then the cell shapes. The cell shapes are nothing but here. The geometric shapes cover the entire region without overlapping with equal. So I am repeating, the geometric shapes cover an entire region by the base station without overlapping and with equal area. That is the use of the cell shape. So by using hexagon, the fewest number of cells can cover geometric region, and the hexagon closely approximate to the circular radiation pattern. So what is happening here? Circular radiation pattern is nothing but in all the direction the station can cover in all the directions, and with the same radius the base station can cover the region. So it would occurs the omnidirectional antenna. So omnidirectional antenna here it is nothing but the antenna which covers in all the directions. That is the omnidirectional antenna, right? So these are the circles, and this is the equivalent triangles, equilateral triangles, and these are the squares. So these are the different cell shapes. So different number of cell shapes are available, but we prefer the hexagonal shapes only. See here, the cellular geometric square and hexagonal pattern. So these are the square and these are the hexagonal pattern, right? So what is happening in hexagonal? The radius of the cell is equal in all the directions. So because I see here, so here distance is seen, but what is the difference here? The coverage area, overall coverage area will be increases here. That's why we are using hexagonal shape of pattern. And the next one is the frequency use pattern. So what is the frequency reuse pattern? So here in the frequency reuse pattern only happens in the cell splitting process only. So in each cell different frequencies are available. So see here for example here F1 to F7 different. So here number of cells are available. This is the 7 cell reuse cluster. So what is first of all, what is the reuse, frequency reuse? So see, by limiting the coverage area to within the boundaries of a cell, the same group of channels may be used for cover the different cells that separate from one another by distance large enough to keep interference level within the tolerance limit. I am repeating, by limiting the coverage area to within the boundaries of a cell, with the same group of channel may be used to cover the different cells and separated from one another by distance large enough. So the design process of the selecting all the allocating channel frequencies for all the cellular base station within the system is known as the frequency reuse pattern or frequency planning. I am repeating, the design process of selecting and allocating channel. I am repeating, the frequency reuse is nothing but the design process of selecting and allocating channel frequencies for all the cellular base station within the system. For example, this is the system. In this system, we have different frequency, that is cells. This is one cell, and this is another cell, and this is one more cell. I am taking 1, 2, 3, 4 here. Fourth one is here. And this is the fifth one. And here it is sixth one. And here it is seventh one. So this is a system. This is a complete system. And I am taking 1, 2, 3, 4, 5, 6, 7. So 7 cell I am taking here. So I am taking here 7s only. So here the design process of selecting and allocating channel frequencies of for all the cellular base station within the system. So for example here 7 base stations are available. So for these 7 base stations I am selecting, allocating channel the same frequency band I am allocating to these 7 cells. So this is the frequency redesign or frequency planning. So see here the blue color cells are available here. These are the F1s, right? See the cell number here it is. I allocated that is F1. So these F1s are nothing but here frequency reuse distances here from here to here. So see here, this is the distance, right? So this distance is nothing but here reuse distance D. And see here orange color lines are also available here. These orange color lines. So what is happening here? The reuse distance from this one to here, this is the frequency reuse. So the orange color patterns are here nothing but here. These are the same frequency band channels. The same frequency band channels are here for the reusing of the frequency bands. The frequency is concept in the cluster pattern. So consider a cellular system which has S number of duplexes. So already we discussed what is duplex. The duplexing is nothing but transmission of the data, way of transmission of the data from the source to the destination, right? So here I am considering a cellular system which has a total of S duplex channels available for the usage. So the S channels are among the dividing into N cells. The S are dividing into N. So N here it is a cluster. I will define what is a cluster. So each cell is allocated to group of K channels. So here N cells, K channels. So the total number of available radio channels can be expressed as S is equal to K into N. So here K is nothing but group of channels. The N is nothing but here number of cells. So see here 1, 2, 3, 4, 5, 6, 7. So here K is nothing but here each cell, the channel, each channel is indicated with K. And here N is nothing but here number of channels available within the system, that is, or within the radio channel or regional. So that is N. So what is happened here? The total number of available radio channels can be calculated as S is equal to K into N. K is nothing but here group of channels and N is nothing but number of cells. So the N cells which collectively use the complete set of available frequencies called as a cluster. I am repeating the definition of the cluster here. The definition of the cluster is nothing but the N cells which collectively use the complete set of available frequencies. So see here, the 7 cells are available. These 7 cells can complete set of available frequencies. These all can collectively use the set of all the available frequency channels. That is called as a cluster. So basically the cluster size is predefined. That is the 4 cell cluster, 7 cell cluster and 12 cell cluster. And here the frequency reuse factor is defined as F is equal to here 1 by N. This is the frequency reuse factor here. So totally here the duplex channel, the number of radio channels are available, it is calculated by S is equal to K by N, K into N. And here the frequency reuse factor can be calculated F is equal to 1 by N. So what is N here? N is nothing but number of cells within the cluster. Next, the reuse distance. Just now we saw that reuse distance here. So here this is the reuse distance from this cell to this cell. So always we can calculate the hexagonal shape. For the hexagonal shape of cells, we can calculate the distance. Reuse distance is equal, the D is equal square root of 3n into R. So here n is nothing but here the reuse pattern, that is number of cells available, that is the cluster size. And here R is nothing but radius of the system. And here just now we discussed that the reuse factor, the frequency reuse factor here is nothing but here. The F is equal to 1 by N, right? But in the reuse distance, the reuse factor is defined, that is calculated by Q is equal to D by R here. So already we know D is nothing but here square root of 3n into R. So here then the Q is equal to D by R. The D already we know the value square root of 3n into R by R. So RR is cancelled, the square root of 3 into N. Then that is the reuse factor in the frequency reuse pattern. So how to calculate the reuse factor here in the within the cell or within the cluster, that is Q is equal square root of 3 into N. And N is nothing but here number of cell in the cluster. Then see, the cluster size here, the number of cells per cluster is given by the total number of. So for example here cluster size is basically changing, right? 3 cell, 4 cell, 7, 9, 12, 13, 16 like that, right? So then the N is equal to given as I square plus Ij plus J square. Then see what is I, what is J. So here when the cell we are taking as the 60 degree of that I into J. Then I to J is here, I is nothing but here the horizontal and the distance make from the angle make from the transmitted signal to the received signal, that is nothing but here transmitted pattern to the received pattern, that is 60 degree. I am taking 60 degrees of it. So where Ij's are integers here, I into J are the integers. So then automatically I am taking here the N is equal to I square plus I into J plus J square. So this is to calculate the number of cells available within the cluster. And here the examples of here N sizes are here 1, 3, 4, 7, 9, 12. So basically we took the 4, 7, 9 only. The popular values are here N being 4 and 7 only. That is the cluster size. And the popular value of 4 and 7. So here the popular of 4 and 7 only, right? So I am taking 4 and 7 here. So the I direction and J direction is here. And then see here. This is the I direction, this is the J direction. For example, I am taking, this is the cell within the cluster. So this is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 7. So I am taking 7 cell cluster. So in the 7 cell cluster, I am taking I and J. This is the I direction, this is the J direction, and the angle between this is 60 degree, right? And this is the image here to represent the popular of 4, 7, and 7 cells here. These are the same. So cluster size with n is equal to 12. Then I value, what is I value and what is J value. And at the same time, the cluster size is 19. Then the cell's I value is 3 and here. So see, I value is 3 and the J value is 2 here. Then this is the structure of the cluster, and this is the cluster of the size when the n is equal to 12 and it is n is equal to 90. Clear? Next, same as here, n frequency reuse pattern here, and it is co-channels, co-cells for n is equal to 90. Let's see, 1, 2, 3, 4, 5, 6, 7. So here 7 cells, by using 7 cell cluster we are designing the 19 cell cluster. The same, see here, this is also 7. So 1, 2, 3, 4, 5, 6, 7 cell cluster, this one. And this is also frequency reuse pattern, the 7 cell cluster. And see here, 1, 2, 3, 4, 5, 6, 7. This is one cluster. And here also same 1, 2, 3, 4, 5, 6, 7. And this is one cluster. So here 2 cluster. And here D is nothing but here the distance reuse pattern. So here D is nothing but here distance reuse pattern. So this is the center point of the base station and the cluster, and this is the center point of the cluster. So from here to here, that is D. That is the distance, reuse distance. So the formula, already we discussed that the formula to the total number of radio channels. So here K is nothing but number of channels and N is nothing but number of cells with the cluster. So already we discussed this topic. That is, the S is the total number of available duplex channels or radio channels available in the system or cellular system. The N is nothing but the number of channels per cell, and N is nothing but cluster size, that is cell size. So here, if the cluster is replicated m times, repeatedly m times, then the total number of duplex channels can be measured, the capacity, that is C is equal to M into K into N. So already we know K into N is equal to S, right? So then here, if the number of the cluster size is replicated time m times it is replicating, then to calculate the measure the capacity of the system, here it is C is equal to M into K into N. So already we know K into N, then it is MS. C is equal to MS. To calculate the, if the m number of cluster size are increasing, then the duplex channels, how many duplex channels or radio channels available in the this capacity, that is measuring of the capacity. This is the frequency reuse pattern. The circle with here it is the distance, here circle with the radius D, and here also circle with the radius D. Just now we discussed this. So here, this is the one cell, one cluster is another cluster. So different clusters are so replicated m times. The cluster size is replicating m times. So this is the images are representing here. The m number of replicated, the cluster size is replicating here. So see here, the frequency reuse pattern n is equal to 4 here, and here it is n is equal to 7, and here it is n is equal to 19. So this is the m, the replication of the cluster size m times. Then these are the images here representing here. So what is the use of frequency reuse? The salient features of the using frequency reuse. So the frequency reuse can improve the spectral efficiency as well as the quality of the service or signal quality. So what is happening here? When the frequency reuse pattern is improved, then automatically the spectral efficiency as well as the signal quality will improve or increase. So the frequency reuse classification scheme proposed for the GSM models only. So what is GSM? Global System Mobile Communication. Here it offers the protecting against interference. So here, when the frequency reuse is introduced, then automatically here the interference is decreased or minimized. Interference is minimized. So the number of times the frequency can be reused and depending on the tolerance capacity of the radio channel from the nearest transmitter by the using the same frequencies. So in frequency reuse scheme, the total bandwidth is dividing into different subband, because of here the same frequency band we are using for the all the number of channels what are available within the system, right? So that's why what I am, the total bandwidth we are dividing into different subbands and that are used by the base stations. The frequency series scheme allows WiMAX. Wireless max, that is, system operates to reuse the same frequency at the different cell sites. So these are the silent features of the frequency reuse scheme. Next one, the channel assignment strategies. So what is here? The frequency reuse nothing but here, the frequency reuse planning nothing but here, the planning and assigning of the cells, that is assigning of the channels. So here the channel assignment strategies are basically two types of channel assignment strategies available. That is, one is fixed channel assignment. That is, the second one is dynamic channel assignment strategy. So the frequency reuse scheme that consistently with the objective of increasing capacity and minimizing interference. So the frequency reuse scheme is consistently with the what is the use of frequency reuse. So the frequency reuse, it increasing the capacity automatically. When the capacity is increasing, then automatically the interference will be decreasing here, the minimizing. So the channel assignment strategies can be classified into two types, that is fixed channel assignment, and the second one is dynamic channel assignment. So the choice of channel assignment strategy impact the performance of the system here. So based on the channel assignment only, the system performance will be the system performance depends on only the channel assignments. So the choice of channel assignment strategy impacts the performance of the system. So particularly here, how the call is managed when the mobile user is handed over the another cell. So see here, the channel assignment schemes are fixed and dynamic. So again, fixed here, basic fix, borrowing fixed, and hybrid fix, and flexible fix. And here dynamic is nothing but the flexible dynamic. Again, the flexible dynamic, it carrying the scheduled and predictive. So what is fixed channel strategy assignment and what is dynamic channel assignment, we will see now. So the fixed channel assignment. So each cell is allocated a predetermined set of channels. So what is happening here in fixed channel assignment? Each cell or each base station is allocated to predefined set of channels. So any call is attempted within the cell can only served by the unused channel. So for example here, this is the system 1, 2, 3, 4. For example, I am taking in the system 4 channels are only available. So these 4 channels are predetermined set of channels. So predetermined set of channels here. So any call is attempted within the cell. So for example, one call is attempted by cell 1. Another channel is 4 here. So basically 4 calls at the same time, 4 calls are connected to that system. So what is happening here? So are 5 calls are attempted to the system. So here only 4 channels are available, right? So what about remaining 5th call? So 5th call will be blocked here. In fixed channel assignment, I am repeating. For example, in this system, the fixed channel assignment 1, 2, 3, 4. 4 channels are available. For this 4 channel, 5 calls are attempted here. 1, 2, 3, 4, 5. So here, I am taking 1 ABC. Like that. 1, 2, 3, 4. So A, B, C, D, E. So here 5 calls are attempted here. So A channel is connected to that call. A is connected to channel 1. B is connected to channel 3. C is connected to channel 2. D call is connected to channel 3. What about this E call? So E call here. So in fixed channel assignment, so here predefined channels are set of channels are connected, right? So here the 5th call is automatically blocked in fixed channel assignment. So see here. So any call attempted within the cell can only served by the unused channel in the particular cell. The channel is busy. See here. If all the channels in the cell are occupied, then the call is blocked and the subscriber does not receive the service. So same, this is the pattern. So here 4 channels are available. Only 4 calls are connected to the 4 channels. So 5th call is automatically blocked and the subscriber does not receive any cell service. So the several variations of fixed assignment strategies exist. That is, one is approach and the call is borrowing strategy. So a cell is allowed to borrow the channel from a neighboring cell is set off. All its own channel is already occupied. That is the borrowing. So the dynamic channel assignment strategy. So here the channels are not allocated to different cell permanently. So here in the fixed channel, all the channels are connected, all the channels are allocated to the predefined cells, right? Or predefined frequency channels. But here in dynamic, the channels are not allocated to different cells permanently. Each time when the call is connected, then each time a call is request is made, the serving base station requests a channel from the mobile switching station or mobile switching center. So the switch is then allocate the channel to the requested call following algorithm taken to the account, and the likelihood the picture blocking within the cell. So here no blocking of the call here. So automatically it connected to the neighbor channels also. That is the dynamic channel assignment strategy. So what is the use of fixed, what is the use of dynamic? This is the conclusion here. So according to the MSc, only allocated a given frequency, that frequency is permanently connected, the permanently served for a fixed channel calls. So that is the fixed channel. In the dynamic, that is reduced the blocking call. So in the fixed channel strategy, the call is blocked. For example, the channel is busy or occupied with the another call, then automatically the call, another call is attempted, that call is automatically blocked, the service is not served for the user. But in dynamic, the call blocking is likelihood here blocking, it is reduced here in the dynamic, because of it can increase in the trunking capacity here. Because of how it is increasing trunking capacity, then when the channel is occupied with the another call, then automatically the another call is connected to the neighboring channel only. So automatically then here we can reducing the blocking of the calls, right? So this is the summary of the channel assignment strategy. So again here the difference between channel fixed channel strategy and dynamic channel assignment. So each cell is allocated predefined set of voice channels, right? But in dynamic, not permanently the channels are allocated. So any call is attended with the cell, only the served by the what are the calls are connected to the cells, that only served. The another call is made, the other call is blocked here, but here it is not blocked. So it is reducing the likelihood of the call blocking. So if the channel is set up, all the occupied, the call is blocked, the subscriber does not receive the service. But here automatically the call is connected to the neighbor channel. The borrowing strategy, the cell set allowed to borrow the channel from the neighboring cells. The own channel are already occupied. But here the MSc only allocates the given frequency of that frequency not presently in use. So that is to avoid the co-channel interference, the dynamic channel strategy is implemented here. So the computational load on the system is very less, and increase the storage and computational load on the system. So these are the today's topic. We will come in the next session with the new topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.